The reason why I think this talk is important is because these days distributed systems is getting more and more popular, right? A lot of people think that microservices is a silver bullet, and that's something which you should use to actually solve your high scale problems, right? So I'm not going to talk about what microservices are, because I'm guessing you guys know it already, right? Is there somebody using microservices at scale, or like is there some production deployments that you guys are doing with a lot of components involved, things like that? Any?
We just started, but not in the scale of production.
Okay, cool. What are you guys using? What technology? Java. Okay. Anyone?
We are using Spring Boot.
Okay.
We are into microservices. We are breaking up all. Ours is an 18 years old product.
Okay.
It's a big monolith.
Okay.
We are making it
into microservices, right? Yeah. So cool. So what I'm going to talk today is microservices is a buzzword today, right? A lot of people wanted to go to microservices for some reason, right? My talk is not about promoting microservices. My talk is about these are the few essential things that you will need when you actually go for a perfect microservices deployment, right? And this is like derived from my own experience in working on the field, right? So I'm not going to talk about this is how you do it in the microservices, right? I'm more or less talking about, so I have divided the talk into two parts. In the first part, I will talk about what are the typical problems that you will end up having when you try for a microservices architecture, right? And then what are the things that you can do to actually solve it, right? And then what are the things that you need in your architecture list so that you can have a scalable system, right? So let's get started on that. So generally, right, if you look at the microservices story, right, everybody will have a microservices story, like you said, right? You have a big monolithic application, you want to break that into smaller pieces which does one thing at a time and stuff like that, right? So that is like the common thing which everybody talks about, right? Why you need microservices, right? It's good, really, because it kind of gives you a lot of flexibility in terms of growing your scale, or maybe like maintainability, deploying smaller pieces individually without affecting the other components and things like that, right? So every microservice starts like that, right? So better performance, better scalability. You can scale out things. So if you want, if your program is processing, let's say, 10,000 messages in a second, if you want to scale it out, right, you can add more nodes or more worker machines which will actually scale it out, right? So these are the common things that you hear when you want to go for microservices, right? So I'm not trying to say these are good or bad, right? Because it kind of works for your problem at hand. It might not work. It might overcomplicate whatever you have, right? So let's see what those are, right? So generally, the other thing that we always hear about is the Unix philosophy, right? Anybody familiar with Unix philosophy? So Unix philosophy is written by Ken Thompson, like back in the old Unix days, right? So what he's talking about is every component, right, should do one thing well, and it should just do that thing, right? And then it should pass on all the responsibility to someone else, right? So if you're familiar with a normal POSIX environment, Linux or Mac OS or whatever it is, right? You will see the command line tools that you operate, right? They're basically tiny tools which does only one thing, right? It does that and passes that information to someone else, right? So take, for example, if you want to find a file name, right, in a single directory, what do? You just do ls, you pipe that output into a grep command, and then that grep will go and find out where that is, right? So that is basically the Unix philosophy. So rather than doing every possible thing within the grep itself, right? Grep is very simple. It tells that, okay, I can take input through stdin and then I will process it, right? That's the only thing that it does, right? And what ls is doing is it's actually listing the directories. Now you're combining it, right? So that is essentially the microservices architecture. So you can very well relate the whole microservices architecture based design to the older Unix philosophy, where you say that, okay, do one thing and do that really well, right? The problem with that is, right, people, a lot of, when you design it, right, people take it literally, right, saying that, okay, it should do only one thing, right? And when you define such hard boundaries, right, sometimes on a practical system it's very difficult for you to actually scale, right? In Unix, it works because Unix tools are very, very small, right? And then they are, Unix tools are created to work in the user space, right, in your personal computer, right? And where there is no worry about performance, there's no worry about scalability and things like that, right? You have your own time, and then you are just combining multiple tools, right? So what I'm trying to say is, like, you need to understand when people say you're using microservices and that maps to Unix philosophy, or do one thing at a time, right? It's not a strict boundary. It is something which you need to tweak it based on what your problems are, right? So I've seen a lot of applications in reality where they follow it literally, and then they say that, okay, this is not my responsibility, I will hold on to this, to some other component, right? That kind of causes a lot of change. So when you try to do performance optimizations, or when you try to find out why something is slow, right, you will have hard time in figuring it, because your code goes all over, right? Or the simple message that you send out just goes all over. So while it's a good thing, but you have to be very careful in saying that, okay, this is how it works. So yeah, so this is the reality. Distributed systems are very hard to work with, right? What you're doing is, right, so you can simply say that monolith is simple, right? Because monolith is just a single piece, right? You know it in and out, right? Over a time it becomes like a maintenance burden, right? But when you compare with a fully blown microservices or a distributed architecture, it is still simple because it's just one thing, right? But what happens is, right, why people think that we should break it up is because the monolith is kind of reaching a point where it's not able to scale out, or it's not able to provide the features as fast as possible, right? So that's why people break it up. But what they end up doing by doing that is, like, they get into this problems of maintainability, and then so we'll talk about more details on why distributed systems are hard to work, right? Talking about RPZ and things like that. But generally what will end up happening is, like, you will create really huge distributed systems which are hard to work, right? And in distributed systems, right, as I told, everything becomes RPZ, right? So RPZ is like remote procedure call, right? So what happens is, right, so in your monolith application, let's take a simple Java monolithic application, right? How do you share your inputs, or how do you share your messages? You have some reusable jar files which have functions, and then you keep calling that, right? That's a within in-memory or in-proc call, right? But by introducing microservices, what you're trying to do is you're just killing that, and then you're moving that into an RPC call. An RPC call is always costlier than the normal function calls, right? But again, right, that's not a bad thing in most of the cases, right? Because you will have to be very careful in how you design that RPCs, right? So later in the talk, we'll talk about what are the better ways of designing RPC itself, right? In terms of, like, defining the protocols, and then defining the communication patterns and things like that for that. So that we'll talk about it. The other issues with the microservices architecture is generally people face is the discoverability, right? You have this tiny components working together, right? Now there has to be someone who can actually discover all these components, right? If you're familiar with the normal discovery services like etcd, console, and all these things, right? They're basically like a dictionary of servers. So every time a new server comes up, right, it registers itself on the single registry, and then you look up in that registry to actually know where to make that call, right? So these are, again, like, complexities involved in the whole design, right? The other bigger problem that I always used to feel is, like, the synchronous communication is lost, right? Now you don't have a synchronous communication, everything is asynchronous, right? You do something, let's say you have an API where you send a request, right? In a simple monolithic application, it's very easy to figure out, what happens in that, right? Here, that application sends the message to a component which is running in the backend. Then that sends to someone, that sends to someone. Finally, there is like a loop of lot of components involved in it, and then finally you get an output, right? So the whole communication is asynchronous. So it is, you're losing the whole synchronicity, right? Yeah, it is more resource intensive. So you need to have more machines, more nodes, and things like that to work with. You need coordinator systems which kind of coordinates between all the services, and then kind of health checks. All these things has to be in place, right? Now this is my biggest thing. So inability to understand the system as a single whole process is kind of lost, right? Because you have like this small isolated pieces here and there, right? And then when you try to understand the whole system, you are kind of lost. You don't know like what the flow is, right? You don't know when somebody sends a message, then what happens, right? Wherein if I understand, if I take like maybe like go one level above, and then if I see the whole components which involved in a single processing, right? Then it might be very easy for me to understand. So this kind of like kills that. So you need to design your services in such a way that your discoverability is not affected, or your the ability to understand the system as a whole thing is not affected, right? So we can talk about that as well. So the other thing is, right, you're kind of breaking down a big problem into small granular pieces, right? And then these granular pieces are going to come, like work together to actually produce something, right? And then what happens is the ability to understand each simple granular pieces, you will understand that single piece that you work on, but you don't understand how that single piece is actually contributing to the whole ecosystem, right? Because there are like so many components involved, right? There are a lot of overlapping responsibilities, right? So what happens is like you have component 1, component 2, right? Component 1 is doing, let's say, a set of validations, and component 2 is getting the messages. Now there is a question, like should I redo the validations, or should I assume that the validations was done by the previous component and I can take it blindly, right? So there could be overlapping responsibilities. So you end up writing more defensive code, because you are not sure what is actually coming in, right? So the reason why I talk about all these things is not to discourage you guys from using microservices, right? I still think there are a lot of distributed systems is the way to go, because the future is there, right? And systems are getting much cheaper, and then it's very easy to come up with distributed systems. The only reason why I went through all these problems which I faced so far is for you to take better decisions when you try to solve some problem, right? Do you really need a microservices approach, right? If you are thinking that you need a microservices architecture, right, or a completely distributed systems, right, then your problem should be much bigger than these ones that I explained, right? Your problem should be really big so that you can actually live with all those things. You need to also have enough resources to actually work around all the problems that we discussed, right? So we'll talk about what are the things that we need to actually do to actually fix those issues. But yeah, this is the thing what I faced in my real life. So we talk about essential. So in essential, we'll talk about each problem, and then what are the things that we need to actually solve it, right? Or maybe like for a better manageable architecture, what are the things that you need, right? So basically the first thing that we need for sure is monitoring and health checks, right? So again, right, never do a completely distributed systems without proper monitoring, right? Because by monitoring, what I mean is like it could be simple health checks like, is my service up and running, right? Or it could be simple things like, can I send a message to one component, and is that flowing through all the other components where it's supposed to flow, right? There could be any number of monitoring, right? So yeah, things like ensures all components are up and running. Then yeah, it should be easy to identify the malfunctioning component. So generally, a good monitoring system should tell you, okay, this service is down, right? Since some time, or like whatever time it was down, and then it tells you, it gives you an easier way to drill down into the log files and things like that, right? Rather than someone wondering, I send a message and I'm not sure where it is, right? Yeah, so every component, right, should come up with basic monitoring and health checks, right? So generally what people do is, let's take a simple example where I'm sending a message into a queue, right? RabbitMQ, Kafka, or whatever it is, right? And then I have a lot of consumers, which I call as microservices, right? And that consumers, right, maybe like, let's say I'm doing it in Java. Each one is going to be a separate Java project, right? And then I'm going to like start it on my own. So I will say that, okay, I need 10 consumers for this queue, and I need like 20 consumers for that queue, right? Now the problem is, right, when you start a new project or when you start a new microservices, right, unless you specify some sort of a standard of these are the monitoring tools that I should use, these are the metrics that I should collect, right, you will lose complete traceability about that component. That component will be there, but then you will end up like that component will be receiving messages, it's like processing, but then that's kind of isolated from the whole cluster, right? So every component that you create should basically follow a set of components and set of basic monitoring and health checks, right? And then generally what we do in couple of projects that I worked is like we kind of set up like frameworks in such a way that when you create a new project, right, you have project templates, and the project templates kind of set up all the dependencies, all the required common jar files and things like that, right? So that every component is like forced to use the same setup, right? So when you add a component into a cluster, it by default comes with monitoring and health checks. Without that, never ever put that into production, right? This is, I talked about this. So every microservice should collect similar metrics, right? And there should be a standardized set of metrics. A general problem that I've seen is like it's so easy to create microservices. People end up like splitting it so much, right? And then everybody collects the metrics that they think are important for them, right? They might collect maybe like their performance timings rather than looking at the whole system as a single functional unit, right? So every project at high level should basically standardize the set of metrics that they need to collect, right? So that all your components are actually feeding to your central metrics repository, or like it's a common metrics that's collected across all components, right? So a lot of people go for microservices because they want to get performance, right? Because it's scaling out, right? You can scale out, it's small components and things like that. But generally, right, I've seen a lot of cases where it's the other way, right? It kind of kills the performance because now there is a lot of fan out, right? Where you send something, it just goes to some 10 components, they all do something, they all get aggregated, right? So the performance, I've seen a lot of cases where the performance is actually getting worsened, right? So what this is talking about, right? So performance, right? Every component should have performance SLAs, right? And performance is a feature, right? It's not a premature optimization, right? A lot of people think that premature optimization is the root of evil and things like that, right? But what that statement has done is like it has done so much damage that people don't think about performance, right? They just do things in whatever way that they feel like, and then when the system is ready to go to production, they will feel that, oh shit, I should have done it that way, right? So I always think that performance is a feature, and then every single component that you create should have performance SLAs, right? By performance SLAs, what I mean is like, let's say your component is supposed to do whatever it's supposed to do in like, let's say 10 milliseconds or 20 milliseconds, right? You should have assertions which make sure that your component is actually not going above that, right? Your continuous integration or your delivery practices should actually take care of it, right? So yeah, fan out should be manageable, otherwise optimizing performance will be difficult. You guys are familiar with fan out, right? So what fan out is like, it's a simple concept. You just put something, it gets fanned out, to multiple components, right? So let's say I have a job which I'm putting into a queue, right? And that job should be processed. I should send an email about that job. I should upload that job to maybe some S3 bucket and things like that, right? That's the fan out. So once everything is done, right, it kind of merges. Right? So your processing starts like this, then it has multiple components. They all do run in parallel. Once they're done, they just get combined. The problem with fan out is, right, it's like very interesting to work with fan out because you're kind of getting the parallelism, right? And you're just like scaling out, you're adding more nodes and then making your cluster big. But the problem is the fan out is that if you cross beyond a point, right, it becomes like completely unmanageable. You never know like what comes first, and then you never know how the whole fan out is actually working. There could be like noisy neighbors where some process could take more time, right, because your whole merge could be slowed down. There could be like n number of issues which is hard to debug. So you need to make sure that your fan outs are within the range so that you can actually get good performance out of it, right? Monitoring system should have the capability to show the overall performance as a single system, and if required you should be able to break that into smaller pieces, right? So generally I've seen in many companies using performance dashboards for independent components, right? So you tell, okay, can I see your performance dashboard? They will have one URL where their dashboard is hosted, which is like completely different from the other component, right? So if I want to see like a system as a whole, right, I want to see that in a single place where I know that, okay, if I do this action, this is the performance that I'm getting, right? If required, I should be able to basically drill down it and then get a component wise split up so that I know where it is spending more time, right? The reason this is important is, right, unless you try to do it from the beginning, right, it's very tough to integrate it later, right? So you need to at least put enough effort in having that in place, right? So yeah, so basically the performance is a feature. It's a pretty good blog by Coding Horror. This is Jeff Atwood, he's the Stack Overflow founder. So I will share the slides, but if you can Google for it, you will get that article. It's a pretty good article. So yeah, so self-healing, right? This is another important aspect about microservices architecture, right? Your components, right, are coming online and going offline at random times, right? Or when you scale out, you'll have more components running. When you don't have enough load, there are only a few things running, right? And there could be like exceptions, there could be state changes and stuff like that, right? So ideally your component should self-heal, right? If there are errors, if there are fatal errors where you can't recover from it, right? What it should do is it should just gracefully shut down, right? And then maybe like start it in a fresh state, right? Yeah, so failures are like in component should recover from it, goes back to a known working state, right? And you can't deal much with failures. Failures is like often it's going to happen, right? You might get a data format which you don't understand. You might get some extra fields that you're not expected, right? So whatever it is, like fail it and then get it back to a known state, right? That's part of the self-healing. Then there are a few programming languages like Elixir and all, right? They make it very easy to do this because they have built-in support for that, right? So if you don't know Elixir is a language which is created on Erlang virtual machine, right? And then it's a fully concurrent and parallel programming language, right? Happy to talk about Elixir at any time. I work on Elixir, so we can talk about it later. But what Elixir does is, right, it kind of gives you a lot of primitives, right? Like supervisors, like trees and things like that, right? Where it makes it very easy for you to handle failures, right? Because handling every possible exceptions or handling every possible corner cases is like difficult. So what Elixir or Erlang does is like let it crash, right? And then they have enough machinery to actually boot it back into a known state, right? And that is very important for a microservices architecture because your component should self-heal, right? So if you are not using languages like Elixir, right, there are easier way to do that. So I don't know if you guys are familiar with Kubernetes. Kubernetes is a container orchestration engine, right? It's from Google. So what Kubernetes can do is, right, it allows your application to be run inside a Docker container, and then you can host that Docker container in Kubernetes, right? And what Kubernetes does is it kind of orchestrate the whole thing, right? You can define logical layers like, okay, this is my service, this is my main front-end APIs, this is my load balance, right? And then you can say that, okay, if I get, let's say, a request more than this threshold, like scale my services, right? And things like that. And Kubernetes manages it pretty well. And this doesn't have any language barrier, because as long as your code can be run inside a Docker container, it should work. So Java, PHP, Ruby, whatever it is, right? You can actually host it inside a Docker container and then run it on top of Kubernetes. If you use Google Container Engine or Google Cloud Platform, Kubernetes is installed by default, right? If you are on AWS or any other places, you will have to manage the installation yourself, right? But it's pretty interesting, and Kubernetes has self-healing built in. So if there are any exceptions, and if your container got stopped by accident, right, Kubernetes knows what was the initial state. So what it does is it deletes the current Docker container, it recreates that, which means your container is back to the known state. So yeah, that's one other way of doing it. So yeah, this is also important. So this one I tried it on a couple of projects, and like pretty interesting. So I have mixed feelings about this. I don't know if you're familiar with Chaos Monkey. So Chaos Monkey is a program from Netflix. So what they do is, like, Chaos Monkey is like, it just creates chaos in your production environment or whatever environment you point it at. So it's like random guy going and killing services, right? Just to test the reliability of your services, right? Or just to test the self-healing part, right? So what Chaos Monkey will do is, like, on a normal production system, right, it will just kill the services, right? And it could actually cause some downtime if the service was not designed in such a way that it could come up, right? So they are willing to do it in the production environment, but I haven't tried it on a production environment. I have tried it on testing environments, and it works pretty good, right? And by doing that, you will get a lot of bugs, because you're just creating chaos in your environment. So unless you are prepared to manage it, you will not be able to do it. Yeah, so this is about programming language. Generally, right, I mean, personally, I try to stick to not to use so many programming languages across the components, right? A general saying in the whole distributed world is, like, everything is a simple component, right? And I can actually use whatever language that I am comfortable with, right? So I will have my own DB, I will have my own language. So I've seen projects where there are like 5 components, each 5 is written in 5 different languages, right? And 5 different databases and things like that, right? The problem with that is, right, while it sounds really interesting, right, let's say I'm comfortable with Java, let me do it in Java. You're comfortable with in Ruby, let me do it in Ruby. So the main problem with that is your maintainability will be, like, really high, because first you need to context switch between multiple languages, and it's not that easy, right? And then when you look at performance, right, when you try to do some sort of performance optimizations and things like that, right, each language behaves in a very different way, right? And the built-in tools that the language has also varies, right? For example, if I use Golang, for example, right, I have proper memory profilers and proper thread profilers and concurrency detectors and things like that, right? But my other component is in Ruby, or maybe other component is in Java, where I'm not getting it. So my debugging might come to a standstill till the component that is in Golang, because the Golang has that, right? When I jump to some other language, I might not have it, right? And there is, like, a lot of people that are like not comfortable with many programming languages, right? And the way the VM works, or the way the resources are used, right? Maybe Java uses so much memory than a simple Ruby program, or maybe like a simple Golang program. But when you combine all these, right, yeah, maintainability will go for a toss, right? But if it is required, if you have a component which can be done only in Java for some reason, right, then it makes sense to do that, right? Unless if you can like actually say that okay, this can be only done in Java, I think it makes sense. But be pragmatic on that and then choose it, right? So yeah, context switching, profiling, this we discussed. Sharing common code, we have seen this a lot, especially right. You have see, even though you have these tiny components and microservices, right, you're still trying to solve the problem at a larger scale. Your project or whatever problem that you're trying to solve is the actual thing, right? That's the actual project, not these small components. These small components can't be deployed alone, right? You need the whole thing, right? And there are lot of cases where you want to share code, right? And many cases you can't share code because they both are in different languages, right? I have written some sort of a nice maybe like a name parser, or maybe like some sort of a parser in Java, and my Ruby component wants to use it, right? I won't have any way to expose it unless I put an endpoint in my my Java component side, and then my Ruby component side can actually do it over RPC, which kind of complicates the whole design again, right? Yeah, this is again my personal preference. I generally tend to use languages and framework which are lightweight and not very resource heavy. I'm seeing a lot of projects where they use really heavy processing libraries, right, like Hadoop and the whole Hadoop ecosystem, for example, right? Most of the people who use Hadoop, they don't really need the power that Hadoop provides. It's just they think that okay, Hadoop can do everything, right? And then they put that in the stack. What happens is, right, it kind of increases the cost that you need to manage the whole components, because what happens is, for example, if you use a simple messaging queue and a simple clients in Ruby or Golang or like lightweight languages, right? Your resources are not much. You can have a small AWS machine and then run multiple things in that. But if you have a big, like let's say Hadoop based system, right, where it says that okay, my Java heap has to be like 2 GB, right, then you can't really get smaller VMs. You need to have like higher VMs, which increases your cost, right? And those are like unnecessary cost. So that's something which you can work out, right? So my personal choices are Golang and Elixir because I'm like so comfortable with those two languages, right? But one good thing is like they both are like both can be statically compiled, and the distributions are pretty easy to make. That's one other thing that I always think when I do any distributed systems is how fast can I distribute it, right? How fast can I deploy it? In Golang, it's a single binary. I just have to copy it over to the target machine and start it, right? Without worrying about what JDK version, what JRE version, what Java class path, that this and all. Of course, you can do that with the proper DevOps support and then proper startup scripts and things like that. But I'm saying this is much simpler than those, right? Yeah, this is another important part. So communication, right? Again, right, lot of cases what I've seen is like people try to communicate over different components, right, or through JSON or through XML or through any of those loose messaging format, right? It's fine, there's no issue with that, right? But a better way could be using much more type safe messaging formats like protocol buffers, right? Thrift, Apache Avro, all these things, because what this gives you is you kind of defining the message format, right? And the message format is actually shared between components. So a protocol buffer, for example, has language implementations in almost all possible languages. So you kind of define your protocol message, right? And whatever microservice client that you are going to implement, right? All they have to do is get the protobuf file, generate a client for that language, and then use it, right? And it's a binary protocol. The only problem that you will have it is like you won't get a human readable format. You get a binary string in the payload. But for internal communications, it is much safer to use that because you're the whole system agrees on a messaging format. You won't have surprises like my JSON ID has ID in capital letter or small letter, and then you try to read it and then things failing, right? Those kind of issues will never happen. And yeah, sharing context, right? That's one important part in the whole communication. In microservices, what generally happens is, right, there's a whole debate on like how to share the context, right? So let's assume your first component is doing some sort of user validation or user forgery check or something like that, right? It has to get some details and it has to pass on that to the another next set of processing, right? There are like non-standard ways of doing it. People put that in the JSON message itself and then send it. Some people recompute it over the other component. So you need to establish some sort of standards on how you share actually the context, right? So what Google has done is like in Golang, there's a context library which they use it internally. So every request or anything that you want to pass, right? And all their standard library understand context. So it is much easier to pass things around. And context is RPC compatible. So they kind of pack it into message pack message format and then you can ship it, right? So much easier to talk. Yeah, avoid creating RPC component where a simple reusable library is enough, right? This is another thing which I've seen, right? People just create because they think that okay, it's microservices, I want a separate component, right? That might not be true because you don't need a separate component if it is simple as creating a simple reusable library, right? Nothing can beat that simplicity. So yeah, HTTP is not the only communication method, right? There are many other, right? Your internal systems need not talk over HTTP, right? Because internal systems can always talk over other different channels. It could be a direct TCP connection, it could be through a queue like a RabbitMQ or Kafka or whatever it is, right? There are n number of ways that your internal systems can talk, right? HTTP comes with its own overheads and then maybe like you don't need it in your internal systems, right? Yeah, logging and tracing. Yeah, another important part. Every component, right, should do structured logging. Right? Without structured logging, you can't make sense of what's happening in a distributed system. There's so much happening, right? And each component is doing something, this guy is doing something, right? So unless you fix a structure to your log files, you can't analyze it, right? Some developer is like really, he likes logging a lot and then he keeps logging in his own format, right? At some point you will have to make sense of what those logs are. And it becomes impossible for you to do that unless you do structured logging. And what I've also observed is structured logging is something which you need to start early. If you start late, it's very difficult to do that because you'll have to add the logging statements to almost all the code path that you have, right? Which makes it difficult to do it. Yeah, so sharing tools across microservices to support the same style of logging, right? Different languages makes this difficult again. Right, because you can have a simple logging framework that I can create, or which is shared across all my components. Right. Again, there are multiple ways to do that. You could use a completely distributed logger and then write your events into a stream processing system and do that. But yeah, this is another way of doing it. So ability to trace a request all the way through different components, right? This is something which I've seen people miss a lot. When something happens, you need to know where that is in the whole maze. So it might go from component 1 to component 2, component 2 to component 4, right? So there has to be, it could be like even simple as a simple identifier which you put into the first request and that has been carried over all the way. So in my monitoring system, I should be able to query saying that, okay, at what level the whole processing is, right? Or like, let's say if I want to debug it, right? It reached till what point? So I could use I could use a simple ID to trace my request, right? Yeah, don't design too far into the future because you never know like what's going to change. The whole industry is like fast moving and things like that, so don't think too much saying that okay, I need let's say 1 million requests per second at and then design for that, right? Your actual problem that you're trying to solve will be much simpler than that, probably, right? Yep, that's all I had. Happy to answer any questions.